talk about business uses of Ceph. Now, specifically, that deals with mid-range data centers. Right? I've spent my entire career in IT, 30 years this year, building, operating, architecting, troubleshooting mid-range data centers. Now, mid-range doesn't mean unimportant or mid-important, right? The bytes are just as important, there are just fewer of them, right? And what I see, I think I could say that in general, Ceph is looked at, I think it's a misconception, Ceph is looked at as something maybe elitist a little bit, where you have to build a grand scale project, like CERN, like Bloomberg, like DigitalOcean, something really big and really complex. And that's what you do with Ceph. And other than that, it's just a toy. But that's not true. It works just as well in the mid-range data centers. The talk we hear, I was frankly intimidated by Tyler's talk today, where it was like, oh my God, I've been looking at NUMA at cores, and now I have to look at NUMA with chiplets. What am I going to do now? But really, these talks are about, well, how do you, when you push the limits of Ceph at really large scale, what happens? What do you look at? What's under the hood, right? But these problems don't really exist at smaller scales, right? So most of businesses that I know run on mid-range data centers, right? So they're you don't need so many storage nodes. You don't need as much performance. Everything's important. Latency is important, just not at that scale. A lot of times it's said, well, you can have scale or performance. Pick one, right? So performance at scale is hard. All right. So I spent my IT career building open VMS clusters, SGI systems, HPUX clusters, Oracle clusters. Those kind of things. There's some really good best practices that persevere, from those times. They were developed by Hewlett-Packard, IBM, and so on, Xerox. So you can apply them to the world of Ceph. And what I want to do is, I only have 6 slides here of content. Those slides, 4 of them are lines of business for us, paying customers. I started a small company 30 years ago, still have it. So these are real customers. The last 2 are POCs that we're doing, but those are pretty much production grade POCs, so I'm referencing them here, okay? And if you have any questions, the competition remark was a joke, right? So if you have any questions, Ceph community has always fostered cooperation. Sage started, Sage while, and I think that really took hold, and that continues to this day. And also, I put a note on my first production cluster was Cuttlefish, and if you didn't have community cooperation, God help you. If you remember. So yeah, all right. So one use case is we have a $5 billion customer for many years. They used to run on open VMS clusters that I designed. And they're pretty demanding. They're not huge. They're less than 100 terabytes, but they're very latency sensitive. They're pushing a lot of data. It's 24/7 by 365. There's no downtime tolerance whatsoever. So we designed 4 clusters for them. The specs are here. Again, reach out to me. There's no time to go into details, but I'm happy to elaborate. So we're just running block devices. Now what happens is I designed these as Pacemaker clusters for Red Hat, Enterprise Linux. It runs a proprietary database. And RBD is a great resource for high availability LVM that Pacemaker uses, right? That's usually a challenge because you got to deal with zoning, multipath, and so on, right? If you come from the world of legacy SANs, they use that. But not really a problem with Ceph. And Red Hat 8 especially improved on block device sharing tremendously by using set auto activation and system ID. All right, so that's a really good use case for that. All right, Proxmox, that used to be a pretty obscure thing. We've done Proxmox for as long as we've done Ceph, but 10 years. A little over 10 years. And now all of a sudden everybody knows what Proxmox is. And if you don't know, Google Broadcom and you will know. Okay. Yeah, so we have a company. So most of my customers currently are healthcare organizations in the United States, lots of them, and this one customer in Australia. Why? Because the technology, open source technology, Ceph technology is pretty much just universal. You can use it for whatever you want, right? So it turns out it's useful to them. Their entire business runs in Proxmox with Ceph, hyperconverged Ceph. This is basically your mid-range virtualization farm. And it runs perfectly well. There's no complaints, no performance issues, no downtime. Everything's great, right? That's what you expect, right? There's Windows VMs, Linux VMs, as was mentioned multiple times, libvirt, KVM, works perfectly well with Ceph. Bring somebody in from a traditional, again, legacy, traditional, whatever you want to call it, background. Most of America runs on legacy, traditional background IT, right? And so when you tell somebody, well, you don't need to do zoning, you don't need to do multipathing, you just plug and play, it's just there. You want to drive, you just specify that you want to drive, and it's there. So that's how this works, right? Good use case. Been there for a few years. Getting into controversial subjects here. We have, this is my idea of fun. I realize it's special, but we've certified a Ceph implementation with VMware in 2016. We're still on the HCL. Made up a brand called Storsium for that, and went fine. So we did that with iSCSI and NFS. We actually did Fiber Channel as a test. Never did anything with it, but works fine. So all of this is open source. We've used basically Pacemaker clusters as well with iSCSI as a gateway, either bare metal or virtual, either one, works. NFS works as well, and I still have some VMware clusters running with it. We had used something that I didn't put in the slide. So Western Digital, kind of before they ceased to exist as a brand, they developed a really cool caching solution called Enhance IO. I don't know if anybody knows about it. This is like the flash cache, B cache, remember those? So Enhance IO is kind of there, and everybody forgot about it, but you can attach and detach kernel devices with no downtime, which is pretty cool. So that was useful here. All right, Healthcare Information Archive, more controversial because I run ZFS on Ceph. And yes, my name is Alex, I run ZFS on Ceph. And what we found is that, well, basically, if you align, right, so I mean, you know what ZFS purists are going to say. Don't do this, this is anathema. Ceph objectizes 4 megs, right? ZFS allows you to align on 4 megs, and if you do that, it runs fine. And you get all the cool features that I was spoiled by Digital's ADVFS and True64 Unix. Does anybody know what that is? Is anybody in this room? Cool, okay, thank you. Right, I'm not alone. Yeah, so that's like ZFS before ZFS. It's really nice to have transparent volume migration and other features that ZFS has, and very few other things do. So it's nice to have the volume management features. And it's nice to run it on Ceph because you have a lot of storage to work with, right? So healthcare information archives, aren't that sensitive about latency. They're much more, reliability is much more important to them, right? So this was a good solution. We sometimes take a ZFS volume, we export it through, NFS or SMB, and just consume it on, whatever needs to talk to it. Okay, Borg is another project. Does anybody know what Borg is? Oh, cool. Okay, yeah. So Borg is a deduplication project. Came out of Attic, right? So a guy wanted to archive his music library, and then another team picked that up and said, well, this looks kind of nice. We could do what Data Domain does, but in open source, and they did, and it works really well. So you can take that, and then you can put the backend on Ceph, and you have a deduplication archive. I mean, there's some immutability features to that, right? Because if you have an encrypted database of chunks, you can't really modify that. So, I mean, it's not blockchain, right? But it's good enough in a lot of cases. So it's a use case here. All right. So 4 megs is the secret here. All right, Kubernetes. So I have to say something about Kubernetes. I think Kubernetes feels to me like this joke about a bass player. By the time you learn your third chord, you need to hire somebody for bookings, right? That's what Kubernetes feels like. So by the time you read your third book, you get a job. And I'm still intimidated by Rook a bit, and a lot of times I don't know if you really need Rook for some use cases, right? So what happens is also Dan van der Stur's student at CERN developed a wonderful plugin, wonderful operator called the Ceph storage. What is it? Ceph storage interface orchestrator for just persistent volumes. Right, and it works perfectly well. If you just need persistent volumes, there's the CSI, there's the Helm chart, deploy it, takes 5 minutes. And you do need access to monitors, within Ceph, so maybe some firewall work is advised. But you have perfectly good persistent volumes formed as CephFS sub-volume groups, and I'm just using this FFS component of it. And the really nice feature that we found is you can inspect them, right? So if the application puts something on there in Kubernetes, so you create your PVC and it maps to your PV, persistent volume claim maps to persistent volume. If it's CephFS, you can just mount it somewhere and look at it. For whatever reason, you may need to back it up or you need to troubleshoot it, debug it. This is possible here. Okay. And last but not least, RGW. So we started playing with RGW because customer wanted S3. So really simple implementation, right? You take pfSense as the firewall. Right, and then pfSense can actually do HA proxy, sort of in a little more complicated way, where you could just run HA proxy. I didn't find any difference in performance one way or another, given a good network backend. And the only thing is the index pool seems to do a lot better when it's on fast storage. Obviously your data pool for the economic reasons you probably want to put on erasure coded storage. And we ran a Wasabi S3 benchmark, and they're really good results. So it seems like a very viable thing. We don't run this in production yet, but it's a pretty good POC, and people have been hammering at it and with good results.